One way to do this question is to systematically draw all the possible grids. So we could have blue, 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 the first three blue, and then red, red. Okay, they're next to each other. We can imagine like moving them all along, or the two reds along one. So it'd be blue, blue, red, red, blue. And we can just continue to do this. Now those are going to be the only possible ways. Red is always next to each other. I've just moved it along or shifted them around. So the answer is going to be 4. I wanted to talk a little bit more about this. If you have done the topic of permutations, which is not commonly taught at GCSE and so on, then I wanted to talk about how you can get this in a different way, or what if we extended it to even larger grids. Well, first of all, I actually have um, 5 different places here, 5 different options. So one way of doing this is that when I have 5 objects, there are 5 factorial ways of arranging them. However, in this case, we've got 3 of them are the same. So I then have to divide by 3 factorial, and then the other 2 are the same. So I have to divide by 2 factorial. And if you've never seen this before, then it's going to be very confusing. But 5 factorial, I should have said, actually means 5 times 4 times 3 times 2 times 1. So because there are 5 ways you can fit in the first one, then 4 ways the second one, 3 the third, 2, and then 1. So you times them together. Now that's when they're all different. When some of them are the same, you have to then sort of account for that, and you have to divide by, because I could move these B's around. If I had 3 things moving around, and there would B1, B2, B3, then it would be 3 times 2 times 1 ways of orientating them. Now, when they're all actually the same, I need to divide by that. That's why we divide by 3 factorial, and we do the same for R. So I can cancel out the 3's, I can cancel out that 2, and I can cancel out the 2 partially, which gives me the answer of 10. That's a really nice way of working it out. And if it was a larger number, if I had like 10 squares, and 5 of them are, so 10 squares, 7 of them are red, and 3 of them are blue, for example, and I wanted to know the number of possible ways of arranging the grid, then it would be 10 factorial over 7 factorial, 3 factorial, and I could cancel that down. I'm not going to do that here. In this case, actually, you could use a similar approach right from the start, because they have to be next to each other. We can basically treat R and R as one single thing. And so now I can just say, actually, there's 4 things that I am rearranging. These two have to be next to each other. I have to divide by 3 factorial because I've got all these the same, and that would give an answer of 4. Okay, it's probably easier in this situation to write down all the different arrangements because there's only 4 of them. But we could, if it was a larger number of things, then it would make sense again to use this kind of math. So I've decided to talk about it a little bit. It's a topic worth looking into more because these sorts of questions will come up quite regularly in the Intermediate Maths Challenge, and often they are later on and more difficult than this one here.